Okay, great, perfect. And just making sure everything's working before we get started. So we are here for our mock interview. So hope you can see the text that is present here, like main.txt, where it's just like a welcome script.
Right. Yes.
Okay, perfect. So sounds good. So let's get started. As I said, like this is our mock interview that we are targeting, and like I'll just quickly start with a short introduction about myself, and then probably I'll ask you about yourself and what's the purpose of this mock interview, what you're looking for, and we'll take it from there. Does it sound like a plan?
Yeah. Sounds good.
Okay, perfect. So I'll keep it short. So I'm in the tech industry for like close to like 7 years now. I've been interviewing candidates for different roles, like college level positions as well as lateral hires, and even like at a point of time like manager level positions. Like for the last like 5 years now, I've been dealing with the different kinds of requirements, different kinds of people, where we have been interviewing for something like a back-end role, front-end role, full stack roles, and stuff like that. So it's been a quite a good of an experience. And yeah, coming to my technical background, I primarily work on the Azure cloud. I have a little bit of experience on the AWS cloud as well. So I'm primarily a back-end developer, but yeah, at times I do a little bit of front-end. But yeah, I'm more of into data engineering, where we process like terabytes of data with 99.99% accuracy, and that's what I'm is an introduction about myself. So does it sound good? So why don't you take a minute or two to introduce yourself and let me know what you're looking for and like what's happening with you right now.
Yeah. So I'm a software engineer as well. I've
Mm-hmm.
got about 5 years of experience. I'm a
Okay.
full stack developer, and then I also work on
Okay.
mobile app development. And then
Mm-hmm.
in terms of what I want out of this interview, I guess is I have a Google phone screen coming up, so just
Okay.
trying to test the waters and kind of get used to interviewing. So yeah.
Okay. That sounds good. Yeah, and good to know that. And yeah, thanks for mentioning that because I'm pretty much aware of some of the patterns in which Google interviews. Again, I'm not like I don't know exact the questions that they'll be looking for, but the standard of the questions or the format that they will kind of be looking forward to. Okay, fine. That sounds good. So I'm assuming that's the main requirement where you are having a phone screen with Google and you want to have like a mock. There's a mock interview, but let's try to treat it like the original one. So I'll be sharing your question right now over here, and you can select a language of your choice from the top drop down. Where I think right now plain text is selected, and we can get started with you solving the problem.
Okay. Do you want me to use
It's
like a language or?
it's about it's completely your choice which language you want to go ahead with.
Okay. Like mind if I use the plain text? I think they just use a Google Docs for the interview, so
Oh yeah, I understand.
kind of want to
Yeah,
get
we're not
used to
going to
that.
probably execute anything as of now, but yeah, it's up to you. I just thought you were, if you wanted to write it in a particular language, which yeah, plain text is also fine. But we're not looking for like just like pseudocode. We want the actual code, like maybe in one particular language that you can select. Does that sound okay?
Okay. All right. Yeah, I'll
Okay,
do a
perfect.
language then. I'll do
Okay, it's up
Go.
to you. So yeah, here I think in this environment we can execute it maybe for our testing and if our implementations are accurate. But yeah, since you brought up the topic of Google, yes, they don't really want you to execute. But maybe the phone screen, uh, I've heard they might want you to execute, but it's like a question mark always. So let's not worry about that. Let's just focus on writing something and see how it goes. So this looks like go, right? Okay, sounds good. Let me add
Yeah.
a comment here so that I can share your question real quick. Just give me a moment. I mean, we have overall the same time to 1 hour, but let's not take it too much hard on time. But yeah, let's just be conscious about time at least, so that we
Okay.
know
Yeah.
how fast or how slow we're implementing things.
Yeah, for sure.
Okay, let me ask you a quick question. One moment. Let me paste the question, and I'll give you because this question particularly requires like a diagrammatic view to it. I'm gonna. Can you can you open up the drawing mode on the top left that is okay?
Yeah.
I'm
Yeah.
just drawing a circle. Hope you can see that. Okay, great. Let me just
Okay.
remove
Yeah.
that from there.
Yeah, I can see that.
Yeah, just making sure we are on the same environment. Yeah, I'll show you the diagram over there that is required for the question once I finish presenting you the actual question. So just give me one
Okay.
moment for that. I'll be quick with you. Okay, here's the question. So basically, let's say you're given a linker list with a next pointer and a random pointer to any of the nodes. So you need to make a copy of the linker list and print it for us to verify it. So what that means is now coming to the diagrammatic thing. If you can open up the window that we are seeing, I'll share you a
Right.
quick thing over this. Give me 1 second. I have it copied here, so I can just take the same thing and share it to you across, I guess. looks like this does not allow me pasting it, but I can quickly draw it up for you. That's fine. So assume this is the linker list. One is the start node. It is pointing to two, which is the next pointer that we spoke about. Let's say three is there, which points to four, and let's say four also points to five over here. So these are the next pointers that we spoke about, which is like a general linker list, but we have something else called as a random pointer, where one points to two, which could look straightforward, and we have only one random pointer per node. Two might point to four instead of three, like the next one, where three might point to itself like a random pointer, and four and five might not have a random pointer also, which can be null. So basically, we want to make a copy of this linker list, like a separate copy, and print it to the console to verify if the copy was successful. So that's basically the question. So it's up to you how you want to solve it. Like you want to discuss your approach, or you want to jump into code. It's completely, just like a regular interview. So let's go ahead.
Okay. Yeah. So yeah. First, I'll maybe clarify some things. So
Sure.
to start off, do I get a like what do I get? Do I get a random node, or
You
like
get
in this
so
example, would I get? Yeah.
you're given a linker list, so you'll get a root node. So I think you can create the test cases for this one yourself, uh, and we can go ahead. I have given the example
Okay.
there. So you'll be given a root pointer of the node as the input, which is in this case like the first node.
Okay. So I get be given node one,
Yep,
right?
that's the only input, which is one
Okay.
pointer.
Okay. Yeah. I guess I can at least create the.
And feel free to ask a question at any point of time. I'm always here for a discussion.
Okay. Yeah. So I'll just write out the signature real quick. So it would be what to copy. So copy link list, and then you're given a root, and then I guess it'd be like a node, some type of structure. Okay.
Yep, that's the exact structure.
And so this is always going to be the first node one, and then
Yeah.
okay. So yeah. So I see. Okay. Um, yeah. So I'm just trying to think of how to traverse it, and then I think the random nodes is kind of hard. So I think I
Take your time.
could probably traverse it. Yeah, I think you could probably traverse it the first way through and do like the 1 to 2 to 3 to 4 to 5, and I could recreate that pretty easily. But then setting all the random pointers, that would be a little bit more difficult. Yeah.
Okay.
So yeah, one way maybe I could yes start off by doing that first part, and then just doing like copying the first regular linked list, and then I would loop through it again, and let's see. I need to handle those random pointers. Um, so and
So
it's
you're
I
clear
guess
on
are
how the
the
random pointer works, right?
right. So it just points to any other node, and it could be
Okay.
anything.
Yep.
Right.
Yeah.
And then
So
yeah. So are these values are they unique?
so we're not concerned about the values here. So yeah, I mean you can just take them for unique. The question is more around copying or cloning this linker list accurately with all the information. I mean with the exact structure. So which means, let's say,
Okay.
in this linked list you visit any of the node, or you visit the random node or the next node, and you print something, you'll get this particular output, right? 1, 2, 3, 4, 5. Whereas your copied linked list should exactly look like this.
Okay. And then okay. Yeah. So it needs to be uh
So which means,
yeah, it
let's say
needs to be
after I copy the linked list into a second one, let's say I do a new copy here somewhere below, and let's say I change this value of 2 to let's say I make this 7. In that case, right, my copied linked list should still print me 12345, whereas my original linked list should print me 17345 because it should be a
Okay.
complete separate copy.
Okay. I see. Um, okay. So let me just create uh, the node struct. And so this will have some value, which is an int, and then it will have a next, which would be like a pointer to another node. And then it'll also have random, which is also a pointer. Okay. And then, yeah, we would have some node. Okay. Let's see. So I need to copy it, and I need to store it in some way. Um, let's see. Yes. Um, yeah, I'm just trying to wrap my hand. But like linked lists are, I need to really work on them. But yeah.
Yeah, sorry, your voice is not very clear to me, but I can hear you thinking out loud. So let me know if you are not clear on, or if you want to talk out loud about the approach that you're thinking, and we can have a quick short discussion maybe.
Okay. There's a. Let me try the phone because I see a phone
Hmm.
option on here. I can't figure out where my mic is, so it's kind of hard. Let me. Okay. Can you hear
Hello.
me now?
Oh yeah, a lot better actually.
Okay. Yeah. Sorry about that. It's just my microphone.
That's okay.
Okay.
Completely
All right.
understandable. Go ahead.
Okay. Let's see. So where was I? So so I want to create a node each time I traverse it. So maybe I can have an edge case. Here, I'll write the comments first. So edge case if root is null, and then I want to create node and traverse. So okay, one quick way of doing this, maybe I can
Hmm.
map the node that I create to the node that I'm trying to copy, and then when I
Okay.
iterate backwards, I use that key to figure out what random node I should go to.
Okay.
Um,
Hmm.
so let's see. So return, just in case. Yeah, and I want to return the copied node. So let me over it. So I'll create a dummy, point to the root, and then this will be my basic structure. Uh, so this will just be my basic kind of traverse structure. So dummy would be equal to dummy.next, right? And so I need to create a copy each time. And so I would store this in a map, node map. And then it's going to be a map that's going to point to, it's going to be a node, like a pointer to a node, and it's going to point to a node in the original list. So it's going to point new node pointing to old node. Okay. So I will say that, or actually, yeah, I need to point probably the old node to the new node that we're creating. And then, okay, so will be where I create that node, and it will have value of dummy.file, and yeah. So I guess I'll initially create all the nodes and pointers, and then maybe loop through it again to like do that over. Let's see. So this should be an address. So
Let's not worry about running this, so you don't have to have it like super syntactically correct, but it's good to have it. So yep,
okay.
I think you're making progress there. I can see that. So okay.
Okay. Then let's see. So yeah. Okay, I think I need to create the node first so that I can reference it later. Or at the the old node. Right, because this is going to point to the old node to the new node. Maybe not. So I can do like this. I could grab the I would pass it dummy, and then this is wrong actually, because yeah, should be doing the old node, so should be dummy points to the new node. Shouldn't be that. So it should point, the old node points to the new node, and then if I am looping over it again, I can say this value, which is a pointer, so I can point to the object, will be, so its dot next value is going to be the next node. So it's going to be whatever I get for this, and then the same thing for random. So it's going to be the random, and then that's going to point to that. Then I'm going to return the copy, which I can just use my node map for that. So it'd be this. Okay, so yeah, just to reiterate, I loop through it to create kind of the initial copies, and then I loop through it again to capture the next and random values. And I use a node map to reference the pointers of the copies that I made. So dummy.next, it's the value, it's the pointer of the original .next value for dummy, or for my group. And then that gives me some number, and then I use that map to point to the other pointer, or address rather. And then yeah, I populate that way, and then I return that, and I return the original one I created.
I see that. So I can hear you explaining it. So you're completed with the solution, or are you still trying to handle anything on this?
Yeah, I mean, So yeah, there's probably ways I can optimize this.
Mm-hmm.
Um, but yeah, if we wanted to
So
try and
yeah,
optimize it, we can. Or if yeah,
yeah,
maybe
let's come
something
to the
else.
optimization later. Just give me one moment. I'll just take a look. I'm just like following the code as you write, but I'm just gonna check few things. Just give me one quick moment. So I'm just trying to,
Okay.
because I'm not super familiar with Go, but yeah, this still makes sense.
Okay.
So you have like a node map that you created. Okay, map of node. So you're having your root as your element. You're making your dummy equal to the root. Okay.
Great.
You're creating a dummy pointer which is out of the root. You're having a double pointer. Okay, while dummy not equal to null. Node map of dummy is equal to,
Great.
okay, you're basically still storing your root there. Mhm. So this loop will populate your map with the, I'm just curious, I wanted to ask you questions on this, so I hope you can still
Yeah.
hear me.
Yeah.
So
Yep.
you created a map, right? And I can see that this is the node map that you created, X versus Y, and you are populating that with the dummy, which is the pointer, and I think you're taking the value and everything into consideration. Okay, but and you're doing a dummy dot next. So where are you handling the random pointer here?
I don't. Um, uh, right. Yeah, I don't handle it in this section. I handle it in the next section.
Hmm.
So I'm
Okay, so
creating, right. And
go
maybe
ahead.
I'm assuming something there. Maybe I'm assuming that a random pointer points to a random value or a random node in the list.
That's a correct assumption. It points to some random
Okay.
position in the list.
Okay. Yeah. So, yeah, the reason I don't do it here is because
Hmm.
I'm just iterating through the like maybe flat structure of the list, and I'm creating all
Hmm.
of those nodes first with their
Okay, so
corresponding
basically
values.
that makes sense. Okay.
Mhm. Yeah, and then yeah, so and the way I'm populating my map is I'm pointing the old node to the new node, right? So I don't handle the random case here just yet. I handle it in the next loop down here, um,
Hmm.
and I get it through that node map.
Okay.
Um, so each of those, like, yeah, down here, right? I'm populating the dot next, but the way I'm
Hmm.
populating it is I'm getting the pointer from the original, like, original list, and then I'm
Okay.
populating that dot next, and then I'm doing the same thing with the random down here. So if I just feed in this dot random, it'll be uh, some address of whatever node we copied or we were
Hmm.
creating earlier, and then so that's how I can point it to the dot random as well.
Okay, sounds good. So let's do one thing. So let's have a quick discussion on this question. So again, we're not looking for more syntactical correctness and everything. We're not going to execute this right now, but I have a few thoughts in mind that I wanted to discuss, and we can then try out another question for you. So just a moment. Let's first come back to the diagram here. I'm just trying to find that. Did I lose it somewhere? No, I have it here. Can you open up the diagram on your side so that we can both
Yeah,
take a look at the same thing at the same time? So you can
yeah,
see this, right? 1, 2, 3, 4, 5. I think I changed it to 7 at a later point of time, but that's fine. I think we're understanding that.
right,
So first thing, as I said, you want to create a new copy completely. So here, what you're doing is you're returning your root from the node map. I agree, but first issue that I directly see with the code is we are dealing with pointers here. It's not like any other map solution where you want to maintain a counter or something, but here we are explicitly dealing with pointers. So when you start your dummy at your root, right? So
yeah,
whatever clone that you're creating, let's say the clone that I'm creating, I'm just trying to type out it, draw it here again. So let's say I call it like 1 prime, and this is my dummy, which you created a dummy pointer, okay, but what you're doing is, again, you're pointing it back to the, you're giving a reference to this root itself. So whatever updates that
yeah,
you're trying to make will happen on the parent list, like whichever you're trying here, or maybe I think this part is a little fine. I should be okay. But when you do dummy equal to dummy dot next, it's ultimately root equal to root dot next,
Um,
isn't it?
yeah, I think dummy is the pointer, right? So
Hmm.
that's just some address, and then
Correct.
so yeah, it's pointing to the root, and then when I do dummy equals dummy dot next,
Hmm.
uh, it's saying that dummy is pointing to dummy dot
Yeah,
next.
this part is fine. This is so that you have to iterate through that. I agree, but I'm talking more
Okay.
around the map. So what are you storing in the map? So node map of dummy is equal to you created a new node with the value, and okay, one second. I'm probably go right. I'm probably not clear on this
Oh
part.
yeah.
So hold on. So that's ampersand node val colon dummy dot val. Okay, you're creating a fresh one with the value which is there. Okay, that is fine. And you're just creating the next. So you did your next pointers and everything. Okay, looks good. You're doing your dummy equal to root again. That's also fine. But my only concern is in your map, right? Wherever you stored your. Okay, that's a new node where.
Yeah.
Okay, I think that should be fine. Yeah, maybe. Yeah, maybe probably because of Go syntax I got this wrong, but that should be
Oh, okay.
fine. So
Yeah.
you're doing a dummy equal to root. You're starting a dummy again. So dummy equal to null. Node map of. So all you have your new nodes there. Dot next is equal to. So here you're trying to populate the next pointers again, actually speaking, but your next pointers are not populated. Okay, next pointer is equal to node map of dummy dot next, node map of dummy dot random. Yeah, only challenges this part. So I mean, again, we are not going to execute this, but my thought process is like this. So if you come back to the diagram, right, looks like you created your primes. Like let's say I'm coming back to the diagram here. So I hope you can see that. So you created your
Right.
1 prime, 2 prime, let's say 3 prime, and 4 prime, and 5 prime. Let's assume this part you solved it. Okay. But
Right.
the actual solution to the problem lies, this is straightforward. Anyone would do this, like, just iterating through a linked list and creating a fresh copy, assuming all the pointers and everything you solve it. I think you're correctly using a map. Map is the exact data structure that needs to be used for this. So the point here is here 1 points to this 2. So you need to keep like a diagonal reference like this somewhere. So where you store your random pointer based on the map. So because when you're iterating, you do in the initial iteration, you do 1 dot random, you get 2. If you store that value, what happen is here your 1 prime dot random will go to 2 again. It should go to 2 prime. Does that make sense?
Oh yeah. Yeah. Um, yeah. It should. Um, yeah. So the node map, the values in it
Mhm.
are the pointers to the newly constructed nodes. Um, yeah. So it
I,
should point
I
to those prime values.
no, but that's the whole thing I'm saying. How will
Okay.
it point to the primes random pointer like this when you haven't stored this anywhere itself in the first place?
Um,
So you need to store that particular thing. So here in your map, you're creating new nodes with the value, but you're nowhere storing that uh, reference that this was the random pointer. So maybe let's not spend too much on one question itself. So that's a rough thought process. Maybe once we execute, we might have a little bit more clarity here and there. But overall, the algorithm looks good. Your approach sounds good. So I think that's fine. But yeah, I just wanted to walk you through that process where it's a single iteration, agree, but the map needs to be more around storing the diagonal reference to the random pointer so that when we are iterating forward, we just refer to that. So that should be okay. Let's probably clean this up. Okay, let me share you the second question right now. I'm just gonna share you the second. I hope I'm not going too fast for you.
oh no. Yeah.
Oh, yeah.
Yeah.
Okay, perfect. And
Yeah. I
hope
think this is my first interview, so I hope I'm
okay,
doing
that's
okay.
perfect.
Yeah. All
Yeah,
right.
that's fine. I just wanted to get you through maybe in the 1 hour, 2 questions so that you have the maximum exposure there. So, okay,
Okay.
let me ask you another question. question here. Just a moment. So I'll give you a, this doesn't require a diagram. I can paste in a matrix for you. So the question is here. So assume there is a gold mine that is represented as a M into N 2D grid where each element is the amount of gold present in that particular location. So a gold miner is at the first column and can only move to the right up, which is like a diagonal to the right but to the upwards, and or right downwards, which is a diagonal on the right side to the downwards. So these are only three directions that are allowed. So what's the maximum gold that can be collected starting at any position on the first column? So let me share you a quick example matrix for this. So just a moment. Okay. Do you see this one which I'm pasting here? So okay, I think it's formatting a little bad, but I can move this. So you have like a 3 by 3 matrix. Can you see this here?
Yeah.
Yeah, so 133, 214, 064. So every number is like an indication of the amount of gold that is present in that particular location. So what we mean is the first column here is this one where I'm highlighting like 1, 2, and 0. So a gold miner can start at any of these and can either move to the right or right up or right down. So what it means is, let's say starts at this whatever starts at this 1, they can move to the right, which is this 3, and collect the gold there, or they can move diagonally downwards to the 1 in the center. Is my highlight visible in this environment? I just wanted to make sure.
Oh, yes. Yes, it is.
Oh, yeah, yeah. Because there's no above, there's no other element, so those are the only two directions. But whereas if they start at the 2, they can go to the 3, or they can go to the 1, or they can come to the 6 here, because that's right, right up, and right bottom. And same thing applies for the 0 and to every element they reach to. So as we said, starting at any one location of this first column, we want to find out the maximum gold that can be collected. So a sample output I can give you as well for this one. So which is like this. So the expected output for this one is 12, and the reasoning is, let's say they start at 1 0, which is this 2 over here. They move bottom diagonally to 6, and then they go either to this 4 or this 4, whatever, and the total output will be 12, and this is the highest possible one. Hence, that's the output. So take a look and let me know what you want to do for this.
Okay. Yeah, let me look through it real quick.
Mhm.
Okay. Okay. So they can start anywhere in the first column.
Mhm.
Okay. I see. So this does
Yep.
seem like a
And
dynamic programming question, just because I'm trying
okay.
to find the maximum, and then I'm trying to build off of whatever the last column and or column index or column and row index that
Mhm.
was at.
Okay.
So
You want to write it out, or maybe you want to discuss it out. It's up to you.
yeah, let me see. I can at least maybe write. Oh no, let me see. Yeah, so I just need to figure out how I'm going to have that relation. And then, more than likely, I'll also have to memorize it so I don't loop over the things, loop over the same problems again.
Mhm.
Let's see. So, okay. Okay, so yeah, the first iteration, I'm going to have to loop through all values in a column. And then the next iteration after that will be somewhat confined to only 3 spaces for each of those positions, and then each of those would be 3 spaces. So maybe I could, let's see, call it just DP just to make it easier to write. Yeah, and then so I would need the column index, so I'll call that C. I need the row index. Well, maybe not. Well, yeah, I do need the row index. And then, let's see, I guess I'm getting input, and that would be in the form of a 2D array. Is that right?
Yeah, you have this entire array as an input, so you don't have, I mean, you can write your function the way you like. So the entire gold mine is the input, which is like a 2D array, as we said, but you won't have any particular node as an input because you can start at any node. So you have to calculate across the mine.
Okay, I see. So I'll have like this would be the mining function, and then that would be just uh, oops, that would just be a grid, and yeah, I would just get that, and then okay, I'll call DP here. Okay, so right, so for each, let me just write out this function of what the DP part is going to do. So yeah, given the column and row, move right, top right, or bottom right. So that's what I need to do. And then I would need an exit condition as well. So yeah, the idea is I'll just loop through. I'll just keep increasing the column each time and then figuring out what row to select. So at most this DP function will go right, top right, or right bottom. And then I'll keep moving that column around. And then I need to calculate, I need to return the maximum value I can get from that. And I know I can memorize this, but it's a little bit easier to see the memorization after the fact. So I might just leave that for later, if that's all right. Okay, so let's see. It's going to be like the best result, right? It's going to be the max of maybe I'll write options so it's a little bit easier. Let's do dp of c plus 1, or let's see, rather it's the columns that I need to update. Yeah, so it's going to be c plus 1, and the row is going to also increase, so it'd be plus, or no, I would be, let's see, say I start at 2, this is going to be the same, it's going to be the next column over, and then the right value, so 2, and then 2 would be one less row, and then I'll pass it to the grid, and then I'm going to do this 3 times. So this is just right. This one is plus 1, and this is bottom right. Okay, and then yeah. But I want the maximum of all these ones. Upright and right and bottom right. And I also need to add the current value. So it'd be at a given step in the recursion, I'm adding the current value of the grid and then the max of selecting either upright, right, or bottom right. And then I need an exit condition. So if C is greater than the length, so I'll start with R is. If R is greater than the length of grid, or C is greater than the length of other index, turn 0. And then I'm going to be returning the best value. Okay. Right. So, can you hear me still? Am I on mute or something?
Yeah, I can hear you.
Okay. Sorry. Yeah. So this
I'm following the code that you're writing. So go ahead.
Okay. Yeah. So this, and then I guess I need to call it. So I need to call it for every single row in this column initially. So see. So, and then I'm going to return like my answer is equal to 0. So int equal to max int and dp. And so I'll start from the first column, and then I'll go through each row value, and then I'll pass the grid so it has a reference, and then I would return the answer. So yeah, this is okay. I think this is decent.
Yeah, overall looks good. Yeah, we are also like 45 minutes into the overall interview, so I think we can hold off the execution and we can have like the remaining time for discussion and questions that you might have. So first of all, coming to this particular approach, like first thought, top of mind thought I can share you, not as a feedback, but like a thought process is like, yeah, TP is the exact solution. So had you gone recursive, it would have been n power 3, not 3 actually, because there's a 3 by 3 grid, I'm saying 3, but it's on the order of, it's going to be exponential. I don't remember the exact full complexity, but yeah, recursive is like massive because you keep repeating the same things again, for example, 2 to 3, then 3 to 4, right. That 3 to 4 is also required in 1. So very well that you've gone with the DP approach. That's the best one where you have a n into n complexity, both the time and space, so that looks fine. One moment. Only challenge I see have given a column and row more right top. This part is okay. You're calling a DP of next and next. And it will return best is equal to grid of R plus max of upright. Okay. And the only challenge I saw where is you're returning a 0. So yeah, as I said, we can't like syntactically verify or logically that we're not running this. So overall, the like algorithm and your approach looks good. If someone's like reviewing from a visual perspective and not running it, this looks good. But might have a little concern here. Is it like a return 0 that you need to do, or do you need to do a return of that element? That's the only point I'm coming to.
Right.
R is greater than, yeah, I think that should be fine. This is your case, checking a case where it's greater than the length, right? So basically, let's say you're at this 4 at the last on line 13. Now you're going right, so that's going to be greater. In that case, you want to return 0 for that, which in that case, your function will return 0. Okay.
Yeah,
you're upright.
Yeah.
Yeah, that's okay. I think that makes
0 case. If R is less than 0, that would fail. So I do need to include.
Yeah, that's okay. Yeah, it's not a edge case actually. So that's like a case we.
Yeah.
Yeah, no, that's not the case I'm talking about. It's not about the row getting less than 0. We'll start at the 0 row 0 column. It's more about I'm trying to think around the value that you're returning, which is good. I thought you wrote a different type of a DP, but that's fine. So you're returning 0, which will return 0 into this lines on line number 43, like upright, right, bottom right, 0, 0, 0, and max of them is 0 again at the end of the day. And then you're, yeah, I was just thinking if you miss this part, which is ultimately you have to append it with a grid element, and then Okay, and that will call it recursively, and you should be good. I think yeah, overall, syntactically, there could be here and there a small bug, but yeah, that's fine. Overall, algorithmic wise, it looks good. So okay, hold on. So any thoughts on the complexity of this implementation?
Right. So every time you loop through it, uh, it basically branches off three times, right? So
Hmm.
um, I think the branching factor would be three, and then it's three to the n or something like that. Because each time
Hmm.
you have to loop through all those columns, and each time you're branching off in three different directions. So I
Okay.
mean, yeah, I think the complexity is pretty terrible. Like three to the
Okay.
n, something like
Okay,
that.
let's, yeah, I'll take a look at that, like what's the complexity, and I'll make a call on that later once I submit the feedback for this. So, I probably we missed discussing the complexity for the previous question, so which is a random pointer one. I think the code is still there, right? Do you want to take a look? Assuming it works according to your approach, everything is accurate. Any thoughts like what is the complexity that could be? So your approach was
Yeah.
to use a map, store all the next and random pointers, and point accordingly. Okay, kind of as I said, right? Overall,
Yeah.
it looked good, but maybe there was a bug here and there which we missed, but it should be fine. Like at least when for a person to understand.
Okay.
So what do you think would be the complexity for this?
Right. So it'd be O of n, right? So the first time I'm looping through it, I'm
Hmm.
recreating the nodes, and then I would do that again while setting all the next and random values.
Hmm.
So it would
Okay,
be
okay.
yeah, O of n.
Often for which one? Like time, space, both.
Yeah, it's for time. Yeah, sorry. And then for space, I'm making a copy. So I need to copy it, right? So that would be O of n. And then I also need to store all those values in a map. Um,
Hmm.
but
Okay.
yeah,
Yeah,
I
that
mean
sounds
they're
good
pointers,
overall.
so kind of cuts it down a
Mm-hmm.
little bit. Yeah.
Perfect. Perfect. Yep, that makes sense. Thanks for answering that. So I think we are almost at the brink of time. So yep, these were the two questions that I wanted to just walk you through so that you get a good practice before your actual interview. So good luck with that. So you have any questions for me before we can close this out?
Yeah, I mean, what did you think in terms of my like communication and was
Hmm.
there anything that I should have like done better or um yeah, well, any parts that I should do better or what's
Okay,
kind of your
sure,
overall
definitely.
consensus? Yeah.
Yeah, definitely. I'll share you my top of my thoughts. So point number one. So uh, let's say this was like a hacker rank kind of like a round, right? So it doesn't matter what you talk and what you think of an approach. It's all about if you get the code working or not. So nothing else matters there. But let's say when you're like doing a live interview, like with another person just like me. So my only thought was complexity analysis. I think you need to be more specific there. So second one, I think you got the complexity right. But first, for your, I mean, when I say second, the second code that I'm highlighting, the copied linked list one, your complex analysis was accurate, no problem. But I think for this one, the purpose we go to a DP is so that we have a linear complexity. As I said, right, we can implement this recursively. So it's not going to be three power or anything. A DP approach always has a linear complexity for this.
Right. Yeah,
So
I didn't
yeah,
do
yeah.
the
So don't.
memoization, but yeah.
Correct. That's all. But overall, I'm just saying that that's what it looks like. So what my thought process is whenever like there's a question around complexity analysis, take your time. Don't have to answer it like in the like within a brink of a second or something like that. You can take your time, analyze your code, see what's going wrong, give an explanation of why the complexity is, and that's what I can say. So communication wise, I think pretty good. I was able to hear you and understand you pretty well. Your pace is good. No problem with that. Your speed in writing the code is also accurate. No problem. Yeah, maybe you want to discuss your approach a little bit, maybe with the interviewer, if not like an in-depth analysis, but like top of mind. Like again, you don't want to have like a paragraph kind of a discussion. Maybe points like this is what I'll do, this is what I want to do, and this is how I will implement. So maybe a three or four liner short ones will really set the tone for that interviewer to understand better, so that they don't really have to
Okay.
get your approach out of the code that you're writing. So you can start with an approach and then maybe the implementation. That's like the best pattern I would suggest to anyone. So yeah, those are the top
Okay.
of my thing. But yeah, I'll review this entire thing once again and probably submit my detailed feedback once we're done. So yeah, that's pretty much I can say. Any other questions?
Okay. Yeah. Yeah, in terms of like writing things down, should I write more down, like more more like top or like more of the pseudocode first, or is it okay if I just go into the coding, figure it out there,
Uh,
or
it kind of, I would say you don't require too much. I think you have written few comments here and there where you wanted to do edge case if route is null, map, or I think this should be informative enough. Maybe I can say like only top of mind thought I can get is separate it out like a new line, so that
okay,
you have like that very visible to the interviewer, so that you catch their attention. Okay, this is what I'm doing for this line, rather than just mixing it with the code, right? So it's gonna be a little maybe this one on line 38 gives a better understanding of that part, so that you can catch their
okay,
attention that okay, this is what I'm doing over there. But this one looks good because the reason is here, uh, there's like the sentence is small,
okay,
but here the
okay,
sentence is bigger, right? So if I do this, it's a little tough to read on line 38, 39 now. But if I do this, then it's better. But here it works out because the sentence is small. So maybe those kind of minor tweaks, but yeah, not like a major thing to worry about. I would say overall looks good. One thing I can suggest maybe is, hold on. Yeah, maybe I think your naming conventions overall they're good. Like you're using the length function, you're calling it a grid DP. Uh, Let me see one thing. Hold on. I saw something that I wanted to actually tell you.
yeah,
C plus one. Those are all pretty understandable by any interviewer. So bottom right, upright, right, return best. No dummy. Just give me one moment. I
yeah,
wanted
no
to
problem.
give you one quick top of it. So you called it
Yeah,
root node. I think that's pretty much no. I think I misread something. So yeah, you called it DP. That should be fine because you don't really want to give a fancy name to the matrix and all. Your function DP, and yeah, I think that should be overall good. No, I think it's only on the comments that you asked about. If you could just separate them out and so that you catch the interviewer's attention, that should be a good enough thing.
okay.
Okay, that's pretty much. Any other questions from your side?
Um, no, I guess that should be it. Yeah, do you have any idea of like what signal you would get from me if this was like a phone screen or like an on-site interview? Like I know
Uh,
Google they have like
mhm.
no hire or strong hire. Do you
Yeah,
know
I
like
think all of them would have like every company would have their own signals like strong hire, no hire, and like request for the review maybe kind of thing I would say. So it's tough to really guess that because it depends on a lot of factors. Frankly speaking, as an interviewer sitting on the other side, right? It's like
yeah,
many things that they look at. It's not just like it's actually like scary to know that it's situational also at times because you might be competing with other candidates or you might be the only candidate for the role applying. It depends on the team, the nature of the work, and everything. So I mean, you can't answer that
I see.
question, but top of mind, what I can say is this is on par with a good technical interview for any company because see, none of the questions you stumbled, you didn't run into exponential complexities. You identified the DP approach, which is the core of the problem here for the second one, and you identify the map approach, which is also the core of the problem for the first one. So I think good enough. There should not be a nothing that you should be worry about. I can't really, as I said it, I can't really find out if it's a strong hire or
Right, yeah,
like a
right.
medium hire for this. So yeah, and I think to your question also, right? This is going to be one round, and your decision for hiring is going to be based on like few more rounds, system designs, and whatever. I don't know which exact role you applied for, but I'm just saying. So best thing to do is don't worry about the final result because it doesn't help you in any way. Just like try to
Okay.
answer the question and live
Okay.
and let them figure out what to do.
Okay. Right. Okay.
Because it's
Yeah.
it's just like few unnecessary cycles in your mind which might which you could well spend on your algorithm. I would say.
Right. Okay. Right. So just
Make
stay
sense?
focused.
Okay, perfect.
Cool.
Yep. That's what I
Yeah.
would say. So okay, yeah. All I say is like good luck and see you soon. Bye.
Awesome. Thank you very much. Great.
Yeah, take care. Bye.